Okay, so now because most people are using GoBuilder now, I'm kind of gonna demo a robot. I'm gonna demo building a robot, and you guys can just follow along. So what you'll need for this demonstration is a 10-hole. You need the files for a 10-hole U channel, or a GoBuilder 1201. So this is a quad block, right? You're gonna need any number of axles with an E clip. An E clip is yeah. Let me just show you. An E-clip is just this little clip that acts as a shaft collar, and this is I love this thing. It's so nice for builders because they don't need to worry about securing like bulky shaft collars all the time. So this is your E-clip, um, and yeah, there you go, the Rex E-clip. Now that will be paired with a Go Builder shaft collar on the other end. And I forgot to insert a Sonic hub. Let me go back and do that. You're also gonna need a Gabilda Sonic hub. So let me find one real quick. One sec. I'm getting a bunch of. So you're good. Let me find that Sonic hub for you guys real quick. Sorry, just notifying someone that I'm in the middle of this. But now we're gonna have our Sonic hub. Let's copy this. And by the way, you're gonna. I hate to be that guy, but did I learn basically everything from CAD just doing it, just literally just doing it. So a lot of this, like, oh well, how did you do that, Amit? Well, how'd you do that? How'd you do this? I honestly, it's just now like an instinctual thing, and I think that's the case for any parametric design or any like application that you use. Like for Google Docs, you never be like, oh, how do I insert an image? Well, you just copy and paste, right? So I'll try to be as vocal as I can with this stuff. So what I'm doing right now is going to the thing that I want. I'm gonna right click the component that I want and press copy. Now I'm gonna copy this component and put it in the folder that I want by double clicking the project and then double clicking the folder. So now there's a copy of that item in the folder that I'm looking at. I'm sure if you're a CAD freak like I am, then you know pretty much everything about this stuff. If not, if you're using Onshape, then I don't really know Onshape, unfortunately. So I'm gonna be asking you guys questions. Like, if you want, go in the comments and just be like, oh hey, Ahmed, you're silly for using Fusion 360, and just teach me how to do Onshape, or I'll teach myself at some point. But okay, so we'll go back here, and so we're gonna insert our quad block, insert our Sonic hub, and then we're gonna insert our um our wheels, right? So here's our Sonic hub, and then and then I'll do wheels later. I'll do wheels after doing motor. So also, I want to make things clear to you guys. A lot of these multi-function parts, they're multi-part parts, if that makes sense. Like the motor or the shaft collar or the sonic hub or the axle, actually they come in separate parts. So if I open up here, right here, the reason why these two things are stuck together is because I've created a rigid group. So if you look at joints, I have a rigid group, right? So let's say I were to delete this rigid group, right? So like the stock part would look like this. This is how you get the part from GoBuilder. It looks like this on the browser. This is how it comes together. But look, oh no, this part is not attached. Well, how do I fix that? Right? You don't touch the part at all, and then what you can do is assemble create a rigid group between these two components, and now they're going to be permanently stuck together, right? Now, I advise that whenever you get a part from GoBuilda, from the GoBuilda website and put it in a CAD, always, always, always do this. Because otherwise it's going to mess with your program. You're going to have to hide a ton of stuff, and it's just a complete mess to deal with, right? So, back to the GoBuilda demonstration. So, I do this with every single part I get, right? I check to make sure if it's multi-part or not, and if it is, then I'll just fix it, right? So now we're gonna. This is how I assemble my robots, right? You guys might find it cringe. I honestly don't know. But by the way, we have bevel gears. Where are the bevel gears? That's a good question. I have no idea where they went. It's whatever. I'm gonna go through direct drive system right now. So for direct drive, you don't actually need this shaft and your axle. All you need is a motor, your Sonic hub, your quad block, and your wheels, right? So what I mean by direct drive is you're actually going to have a bunch of different types of robots, right? So you're going to have H drive robots that look like this. You're going to have X drive robots that look like that. You have C drive robots that look like that, right? You have O drives that look like that. So with all these different drives, you have different ways of driving the robot with drive, right? So you have a direct drive, which means your wheels are directly stuck to the motor, which is really good in programming because then you're like, well, okay, my motion will not be hindered by grinding gears, slipping chains, whatever, right? So that tends to help programming a lot, but you can also use gear drives, which are just like two bevel gears. If you know how bevel gears work, then this is a very easy explanation. But basically, a bevel gear is a gear that sits like this with angled teeth. And you can sit another bevel gear on top at 90 degrees and it translates rotational motion. Okay? So that's that kind of bevel gear drive is used a lot by a lot of teams now because you can hide your motors, which is really nice. Hiding motors is always a good deal because you save space, right? You can also do a chain drive, which is kind of frowned upon nowadays because it's kind of clunky. You could use a belt drive, which uses two teeth belt to make things go, right? Sorry. And you could also use a bunch of other wacky stuff. You could use swerve drive, which is done by barely anyone in FTC. I don't recommend it because it's really hard to do. Like only gluten free has made a really successful one that most people copy. So you could also do swerve drive, okay, which uses two differential core. It either is a direct swerve drive, which has one motor for changing like the swervy part and the other motor for driving the wheel, or you have a coaxial swerve drive, which has two motors, one that directs a top gear and the other that directs a bottom. That as it spins a motor and changes the position, or spins a wheel and changes the position of the wheel. So those are really cool, but they're really complex, and I really wouldn't recommend it right now. But okay, so let's move on. I'm kind of getting caught up here. So first of all, I want to before I do anything, I'm gonna ground my piece in space. What that means is right click your component that you want to ground and press ground. So capture position. Now this piece will not go anywhere, right? So now I'm going to uh, move my quad block so it's in the correct position that I want it to be, and then I'm going to use the joint tool. So first I'm going to rigidly joint it so that the two parts don't move when they are put together. So think about jointing as kind of like putting a virtual screw into the part that you want to hold together, right? So now look, like this part is not going to go anywhere. And if I were to unground this, These parts are like rigidly fixed together, right? Oh, shit. So ground, right? So now we have that. I'm going to insert my motor in here. So let's put this motor in the right position. So I'm going to select my motor, spin it around, and then select the threaded holes, and then insert them into the non-threaded holes. Here's something very important that you need to know. Do not put two threads together. I'm begging you, don't do it, because you're going to ruin the thread and you're going to ruin the part, right? So what I really mean is there's ways to attach things, right? If you've been in robotics, then you know how mechanical systems work. Like when you have a screw, if you want to attach a screw into something, you have a nut, right? Now the nut has threads in it. Oh, okay, there we go. So the nut has threads in it, but as the nut is tightened, the screw is tight. But some parts have these threads embedded in them, right? So the motor does, the quad blocks do, and that avoids a lot of like clunkiness and space wasting. It's very efficient. However, you can't put two threads together, so you can't put a nut on a quad block and then drive a screw through it because that won't work. Because the pitch between the one thread and the other will be all sorts of whacked if one is a longer distance than the other. So
I don't mean to interrupt. I've got some theory on TV.
okay, thanks, Dad.
Say hi to your friends. And,
I'll clean up, Dad. Go away. Bye, Dad.
all right.
Sorry, that was my dad. So, yeah, my room, like I said, is completely messy right now. But so now what we've done is we've attached this motor in here, rigidly fixed. So at every single one of these joints, you can imagine a screw in real life going through and holding it down. Okay. So now I want to attach a sonic hub. Okay. So we have our sonic hub here, and I could just spin this around, right, to get to the position that I want. And then I can select the joint tool. Now, in order to select any one of these random points that are here, you select on the face that you want, and then you can drag, and then you can hover your mouse cursor over any of these points, and it will select a point for you. One important thing to note is that you want all of your points to be centered. So when you saw me attach the quad block to this hole here, I was finding the center of the hole of the quad block that I wanted to attach to the center of the hole of the U channel that I wanted to attach. That keeps everything very strict in its position. So make sure you remember that. Well, so now I have my rotational jointed uh, uh, sonic hub, right? And you can see that I'm revoluting it. So if I were to animate, it's going to spin this way when I go to manipulate the model. Okay, now that looks wonky because you can't, if this axle is rigidly connected to its motor, then you can't really do anything about it, correct? So now we have this rotating thing. So if I revert position, now I want to attach a wheel on it, right? Well, how am I going to do that? Well, I'm going to drag in a wheel, and you also have to know something important about how these wheels work to avoid hitting screws on your robot. You have one side of the wheel that's very close to the outside and one side that's recessed. This recessed part here, you see that? You want to avoid attaching the sonic hub onto the recessed part, and instead you want to attach the sonic hub to the part that is not recessed. That will keep your wheel from hitting a bunch of screws and just not working in the real world. Remember, when you're CADing for the real world. So have what my greatest recommendation is be a builder before CAD. Like I swear to God, that's the best recommendation I can give. because as a builder, if you have building experience, even a little bit of building experience, you know how things are supposed to go, right? And that's what you're trying to achieve. So as you can see, I selected the center of this hole and I attached it to the center on the on the Sonicon. So I changed the position to rigid, and there we go. Now we have a wheel that's stuck on a motor that's stuck to a channel, and it spins. So this is really all this jointing business is really important to learn.